LeetCode problem number 743, network delay time. So we are given a network of n nodes labeled from 1 to n. We are also given the times, which is a list of travel times between each nodes, right? So each time here we have the u, v, and w. U is the source node, which is the number itself. V is the target node where it's going, and W is the time it takes. Let's say from 2 to 1, it will take 1 time for signals to travel from the source to target. So the problem is it will send a signal from node K, for example K is 2, and to return the minimum time it takes for all the n nodes to receive the signal starting from the K node 2. So here it asks if it's impossible for all the nodes to receive the signals, then we return -1. Okay, so my solution to this problem is a bit lengthy, but let's go through it nonetheless. So first of all, I have a vector and called the adjacents, and this will basically store the time it takes and the target nodes inside of this vector, right? So let me just let's say I'm using this as an example. Don't need to be too much. Okay, so time is 2, so we have 0. Let me just put it like this: 1, 2, and 3. Okay, so for the first time, we are looking at 2. So over here, we are placing back the pair of time 2, which is 1, and time 1 is 1. Okay, next over here, again, this is at point number 2. So again, we add 1 and 3. Okay, next is 3. So 3, we put another 1, 1 and 4. Alright, so this is the adjacent vector. Next, I have another vector called signal times, and this will basically store the time to receive the signals from all of the vectors, for all of the vectors. So this will actually be n plus 1 in max, so there's going to be 4 in max, right? Because n is 3. Oh, sorry, n is 4, and so there is a 4 here. 4 plus 1 is 5. That means there's going to be 5 nodes. Okay, so after that, I have a priority queue as well. So this priority queue will store a pair. So the first thing you will do is push 0 and k. So in this case, k is 2, so I'm pushing this in. Okay. And here, I make the signal time for the current k to be 0 because we are at the starting node. So k is 2. So signal times 2, 0, 1, 2, this is 0. So while the priority queue is not empty, which is it's not, the current time node, current node time is equals to the top is 0, and then the current node is 2, and then we pop this. So this will tell us that the time to take from k to this node is 0, which of course because we're at the root node, and the current node is 2, right? So next we check if the current node time is more than the signal time we saved for our current node, which in this case it's not, because 0 is less than 0, 1, 2. Yeah, because it's they're both the same in this case. So we just skip past this and we go into this another for loop. So this for loop, I'm iterating through the edges inside our vector here, and storing the time equals to the edge first. And since there is nothing here, right? There's nothing in 0. So the edge of the current node, sorry, so 2, so it's going to be this one, right? So time is going to be 1. Neighbor node is going to be 1 as well. So we're looking at this, right? This 1, 1. So here we are calculating whether or not the signal time in our neighbor node, right? So in signal time, neighbor node in this case is 1, so 0, 1 is more than the current node time plus time. So obviously in max is larger than 0 plus 1, so we have to update it. Update it to 1, because 0 plus 1 is 1. And then we push 1, right, with the neighbor node, which is 1, right? So this is the source node, and this is the time it took from our current node to this node right here. Okay, next we loop through again for the next one, 1, 3. So time is 1, neighbor node is 3. So again, signal times 0, 1, 2, 0, 1, 2, 3. One, two, three. So 1. Wait, did I mess up? This should be 1 instead. Okay. Afterwards, we're looking at 1, 3. So I have to push this as well. So this is 1 with the node 1, with the neighbor node 1. Okay. Next is 1, 3. So 0, 1, 2, 3 in max is more than current node time plus 1. It's more than 1 as well. So we have to update it. And then we push again. So we push. Since this is a queue, if I push it, it will be like so. 1, 3. Alright. Afterwards, this for loop will end and we cycle again. So by doing breadth search, we are now looking at node 1 and node 3. So current node time is now 1. Our current node is actually 1, right? So we are popping this. So we check the current node time. Is it more than the signal time we registered? So current node is 1, 0, 1. And since it's not, 1 is less than in max, that means we can continue. Meaning that there is a shorter path than this in max. So again, we go through this for loop. For every edge inside of 1, but since there is no path from node 1 to another node, so we can just skip past this for loop. Okay, after you skip past this for loop, this for loop will run again, and current node time is 1, and current node is now 3. Pop this, we check again, current node time 1, is it more than the current time we registered? 0, 1, 2, 3. It's not, they are the same, so we can check again. So again, a for loop. So right now we're looking at 1, 4. So time is 1, neighbor node is 4. So here we check if the signal time for our neighbor node 0, 1, 2, 3, 4, if in max is more than 1 plus 1, 2, then we update it to 2, meaning that there is a shorter path instead of in max. Push this into our priority queue. 4. Once that is done, we have finished iterating through the nodes of 3. So we run the while loop again. Now current node time is 2 and current node is 4. We pop from here, check again, is the current node time 2? Is 2 more than the signal time we registered? So current node is 4, 0, 1, 2, 3, 4. Since they are the same, we don't have to do anything about it. Here, this for loop, we check again for our current node. But since in our current node there's nothing inside, right? There's no directions from 4 to another node. So this for loop will basically skip. Now when we skip this for loop, this while loop will end because in our priority queue there's nothing inside anymore. So once that is done, we get the result, right? So this will basically calculate from here. Actually, this should be begin plus 1 should be here. Yeah, this should be 1. Sorry, this should be in max. Okay, so we basically get the max element from here to here, and if you see here, since the result of it is not in max, right, because the maximum number between these 4 numbers are 2 is 2, so we just return 2 instead. Okay, the reason why this is in max, okay, I think I made a mistake here, so let me trace back just a bit so I can point out my mistake. So over here, the queue, we push 0 and k. K is 2. Okay, so signal time k is 0. So k is 2, 0, 1, 2. This is 0. We do the priority queue. Current node is 0. Current node is 2. Current node time is 0. Current node is 2. We pop this, and this is not true because current node time 0 is not more than, right, they're the same. So we go to this for loop and we loop through 2. We get 1, 1. Wait, sorry, not that one. 1, 1. We check again. 1 is not more than in max, so we update it. Neighbor node. This will become 1, right? Yeah, this was a mistake over here. I mistook this as the first one we did. Okay, let me just continue anyway, so we don't have any confusions. So we push the node priority queue. We push 1 and the current node as well, which is 2. Sorry, the neighbor node, which is 1. Alright, so this is the neighbor node that we have to use breadth search to go to next. But we have not finished iterating. There's another node here, 1, 3. So again, here signal time, neighbor node 3, 0, 1, 2, 3. This is obviously more than 1, so we update it and push. Okay, afterwards, our while loop will refresh. Current node time is now reflected on the node it took from 2 to 1, took 1 step, so this will become 1. Current node is 1. Pop this, and since this doesn't trigger, and since there's nothing inside, there's no neighbors for node 1, so this for loop will skip and we go next. So current node is now 3. It still took 1 step from 2 to 1, from 2 to 3, sorry. We pop this, and since there is a neighbor node for node 3, 1, 4, so we have to iterate through. So since this 0, 1, 2, 3, 4, since this is more than 1 plus 1, 2, in max is more than 2, so we update this to 2 and push the neighbor node, which is 4, with the time it took, which is 2, right? 2, 4, right? Time it took is 2 because from 2 to 4 it took us 2 steps, right? Or 2 times. Okay, once this for loop is done, this for loop will run one more time. Current node is 2, current node time is 2, current node is 4. We pop this, and since for node 4 there are no neighbor nodes, so we don't have to run this for loop. Once we're done with that, we calculate the result. The result is from begin plus 1, so we ignore this in max and look from here only towards the end, and we return the result whether or not we have found an in-max or not. Since we have not found an in-max here, the maximum is 2, so we return 2, which is the same as the result when out here. Okay, so this solution is pretty similar to the Dijkstra algorithm. That's where I got the inspiration from. Other than that, that's all I have to show. Thanks.